you just get x. Right? Right? Okay, is that clear? Because that means, in this case it means what? Taking the square root of x squared. Right? The outside function, we talk about this as the outside function. So the outside function is k, and the inside function is g. So the outside function is square root, and the inside function is squaring. Okay? So if you do the square root of squaring, you get x. Right? So we call this the outside function, and this the inside function. So in this particular case, the square root is the outside function, and the squaring is the inside function. Okay, does everyone agree with this? Okay, so these two are called inverses of each other. Because when you do them together, and what I mean by together is when you do their composition, nothing happened. Okay? Okay, can you think of any other examples of inverse pairs of inverse functions? Anybody think of anything else? How about this? F of x equals 10x, and g of x equals 1/10 x. So if you do this one, so that means when the output is 10x, and you put that into here, so you get 1/10 of 10x, which is x. Right? So these two are inverses. Right? Let's check it. F of g. So I need to, so what does f tell me to do? Multiply whatever is in here by 10. So I get 10, this is 10 times g of x, right? Okay, because that's what f says to do. But g of x is what? So I get x. Okay, so those two are inverses, of course. These are also going to be inverses. Right? Of course, right? And of course, those are also going to be, right? Any constants like this are going to be inverses, right? Okay. What other examples of inverses can we think of? Well, you can take one function and then try and figure out what its inverse would be. But that's a little bit of, kind of twisted thinking. But, if I asked you, suppose f of x is equal to 2x plus 4, and then I say, can you figure out what the inverse is? Well, it's kind of hard. I know, for me it's hard. Maybe somebody can do it. Some people are better at this than other people. Anybody do it? Kind of hard. So you want to do this, and then do something else to it, so that you end up just with x. you get old, it's hard to do these things. But I think I could have done it before, but I don't think I can do it now. But maybe somebody can do it. I guess you could do trial and error. Like try something, see if it works. No, fix it a little bit. Something like that might work. Nobody has one? You have it? No? Okay, I know a trick to get it, so if you can't think of it, I'll just use the trick. Okay. So the trick is this. First write it with the y. Okay, and here's the trick. Switch x and y in that equation. So what I mean by that is do this. X equals 2y plus 4. Okay? Now solve for y and you'll have the answer. Okay, let's see. What do you get when you solve that for y? You get 2y equals x minus 4, right? Then divide by 2. Y equals x minus 4 over 2, which I guess we could rewrite as x over 2 minus 2. Okay, that's going to work, actually. And we'll check it, but it will work. Okay? That's a trick. Now just let me point out something about this trick. When we do algebra, you know, like if you have x plus 10 equals 15, and you want to solve that, you can use algebra, right? What do? You can add negative 10 to both sides, right? Add negative 10 to here, and negative 10 to here, right? And then you get x equals 5, right? Okay, so that's called algebra, right? So there are certain things you're allowed to do, you know, in algebra, like we can add the same thing to both sides, we can multiply both sides by the same number, right? And what we mean by allowed to do is doesn't change the answer. So you can see right here that the answer is 5, right? And when you do this, you can also see that the answer is 5. But it didn't change the answer to do this algebraic manipulation, right? So there's certain rules you're allowed to do what they mean by allowed to do is that it doesn't change the answer. But this is not a rule that we ever learned. That you can switch x and y. You can't switch x and y. You will change the answer. That's not allowable rule. Okay, I'm just saying that it will give the inverse, which is a completely different function. Just like we started with this and this. These are not the same functions, right? And you're going to go, when you switch x and y, you're going to go from here to here. So it's not an algebraic operation that you're allowed to do. It just is a trick that will bring you from one function to its inverse. Okay? So that's what we're doing here. Okay, so we found that the inverse should be what, according to my trick? Here. So let's check it. So let's try it. So what did we say? The first function was what?
2x plus 4.
F is equal to 2x plus 4. And the other function, let's call it g, is equal to what? X over 2 minus 2, right? Right? Now, what's the claim? that these are inverses, so that means what? That this should be just x, right? You should just get x. So let's see, what do we actually get? So I have to take, so f says whatever you put in, multiply it by 2 and add 4. Right, but we're putting in g, so we should multiply g by 2 and add 4. Right? And what is g? G is x over 2 minus 2. So what do I get? X minus 4 plus 4. So I get x. Right? So that trick worked. Okay? Everybody agree? Okay, so that trick works. Okay, so what did we just find? That these two functions are inverses of each other. Alright? We just found that these two functions are inverses of each other. Now, let's just make sure that trick actually works with one example that we already did. So we already did we already know that are inverses, right? But let's just make sure of using that trick. So what's the trick? Write that, and then what? Switch x and y. Remember, that's not a legal operation, but, okay, and then solve for y. So it does work. Okay, we started with x squared, and we end up with the square root. Okay? So that seems to work. Okay, any questions by this concept of inverse functions? So two functions are called inverses of each other if what? Let's say two functions, f and g, are called inverses of each other if what? If f of g equals x, right? Or if you want to write it the other way, f circle g of x equals x, right? That's the definition of inverse functions, right? Okay, so we have that. Okay, now, remember, we're trying to talk about logs here. So it's not clear why we had to talk about inverse functions yet. But before we finish, before we go into the logs, let's do one more thing. And that is, let's look and see if there's any relationship between functions and their inverses when we think about them graphically. Okay? Graphically, it's just another way to explore functions or explore things. Okay? So I'll use different colors here for different pairs. Okay, so we had the first pair I think we talked about was x squared and the square root. Okay, so let's draw x squared. So x squared looks like this, right? I don't want to draw too many. It's going to get too messy if I do both sides, so I'll just leave it with this side for now. And the square root of x looks like that. So if I put in 1 for x squared and the square root, what do I get? If I put in 1 for x squared, I get 1. If I put in 1 for the square root of 1, so they cross here. Okay? But this one looks like this. This one looks like that. Okay? All right. What other ones did we do? I think we did 1/10 x. and 10x. I think I'll change it to, well, I'm going to change it to 5x and 1/5 x. Okay? So what do they look like? So 5x looks something like that, right? That's about 5x maybe. And 1/5 x looks something like that. Okay? And then we did the last one was what? This one. And what was the original one?
2x plus 4.
Okay, so that's y equals 2x plus 4. So where's that? That's like, I don't know. I'm going to change the scale. I'm going to put 4 here. This is 1. This is 4. That doesn't work, but I'm just going to do it. 4. So, and 2x is a slope of 2. So, maybe it's like this. I'm just going to make it up. Just going to do it like that. Okay? I don't know. Something like that. Okay, and then what's the other one? X, 1/2 x minus 2. Right? So minus 2, if this is 4, then this is minus 2. And the slope is not 2 anymore. This had a slope of 2. The slope is 1/2. So that's something like this. Okay? Okay, so you get the idea, right? Okay, so we drew functions and their inverses, just as something to do, something of interest would be to do that. Right? You can imagine that somebody who's exploring this concept might say, hey, I wonder what happens when I draw the two functions, right? So they do it a few times, and what do they notice? That a function and its inverse are very much graphically related, and basically they are reflections through this line. Right? You take one and reflect it through that line, you get the other one. Right? And this line is the 45-degree angle line. So that's y equals x line. Okay? So we know now that, or we seem to know, that functions and their inverses have this relationship, geometric relationship. Okay? Everyone understand? Okay. So, all right, now we've talked enough about inverse functions. Okay, now why did we bring this up here? Oh, one more thing. We sometimes use the notation, by the way, for if f is a function, we can denote its inverse like that. That means the inverse of f. So if f equals x squared, then the inverse of f is what? Square root of x. Right? If f equals 2x plus 4, then f inverse is equal to what? X over 2 minus 2, right? Okay, and so this means that if you do f and then f inverse, you get what? X. Or if you want to write it this way, okay? Okay, so that's just the notation for inverse of a function. Okay, now, going back to this. So this is f. Okay, that was the exponential function that we were talking about at the beginning of class. So we talked about graphing that function, right? Okay, now you know, I know you studied this before, so you know what this means, right? This is the log function, right? So if I ask you, what's that? I think you know the answer. Sorry. If I ask you that, I think you know the answer. Do you? No? Forgot? So this means, what number do you have to raise 10 to get 100? So what number do you have to raise 10 to get 100? 2, right? You have to raise 10 to the second power to get 100. So this is 2. Okay, so if I asked you this, what would the answer be? The question is, what do you have to raise 10 to get 1,000? That's 3, right? Okay, and if I asked you this, means what do you have to raise 2 to get 8? 3, right? Okay? So that's the log function, right? I know you studied it. Right? So if I write the log base